Let us see a numerical how we use this enthalpy of formation and combustion and other data in order to find out the enthalpies of reaction. See, the question is that the enthalpy of combustion of benzene is given as 3267 kilojoule per mole, and it says find the enthalpy of formation of benzene given that the enthalpies of formation of CO2 and H2O, CO2 gas and H2O liquid are minus 393 kilojoule per mole and minus 285 kilojoule per mole respectively. So this is what we are having actually the data given. Now when we say that the enthalpy of combustion of benzene is this, it means C6H6 liquid is combusted in oxygen to give you CO2 and H2O. When we balances this, we get 15 by 2 of oxygen, 6 moles of CO2 and 3 moles of H2O. And 1 mole of benzene is being combusted, and in this much amount of energy is being released, it's minus 3267. Now we know that this enthalpy of combustion of benzene will be equal to summation of enthalpies of formation of product and minus enthalpies of formation of reactant. Now let us find out how we can find out this enthalpies of formation of CO2 is already given, it's minus 393, and we are using 6 moles of this. So we will multiply this by 6 into minus 393, and then we will do plus 3 moles of water is being used, 3 into enthalpy of formation of water is minus 285, and we will do the minus the enthalpy of formation of benzene, let it be X, so it is taken as X, plus enthalpy of formation of elements present in the natural state is 0, so it's 0. And this data is equal to minus 3267. When we solve this, we get X as 54 kilojoule per mole. So this is what is most important to notice.